Hi there. This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Higher Tier Paper 3 from Summer 2023. This paper is worth 80 marks in total, and this is the third video of 4. It will focus on questions 14 to 19, which account for 19 of these marks. Edexcel Paper 3s are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 14. OAB is a triangle, so OAB is a triangle, and then OBC is a sector of a circle with centre O. Calculate the area of OBC. Give your answer correct to 3 significant figures. So if I want to find the area of a sector, it would be the angle inside divided by 360 times by the formula for the area of a circle. Remember, this formula for the area of a circle includes the radius, and both of these lengths here are radii. So I need to work out one of those lengths to then be able to find the area of this sector OBC. So now I'm going to use this triangle here. So I'm going to use the triangle OAB, or whichever way you want to call it. They called it OAB, so let's go with that. And I'm going to find this length BO. And I'm going to find this length using the cosine rule, because I've got two lengths and their enclosed angle. So I can use those to find this missing length. So the cosine rule would give me length OB squared is equal to 9 squared plus 6 squared minus 2 times 9 times 6 times cos of that angle 35. So OB squared is equal to 9 squared plus 6 squared subtract 2 times 9 times 6 times cos 35, which is 28.53157922. This is OB squared. We just want OB, so we're going to square root that, which gives us 5.341495972. So this is the radius of that sector. So now I'm going to substitute the radius of the sector into this formula. So the angle inside that sector is 80. So it's going to be 80 over 360 multiplied by pi multiplied by this, the radius squared. And because I haven't cleared my calculator, that's going to make it easy. So don't clear your calculator at this point, because then you're not going to have to enter all of this in. So we're going to put 80 over 360 times by pi times by the answer, because I didn't clear that answer for the radius, squared, and press equal. So that tells us that it's 19.91879993. So this is the area of the sector OBC. Double check what the question's asking for. Give your answer to 3 significant figures, okay? So 3 significant figures going on this line here. So 1, 2, 3. That 1 isn't going to change the 9. So it's 19.9 centimetres squared. (15a) Factorise a squared subtract b squared. So this is the difference of two squares. A is squared and b is squared, and the subtract gives us the difference. So the difference of two squareds means we need a positive and a negative version of this term here, so that the AB terms, if we were to expand those brackets, would cancel out to leave us with a difference of two squares. So we're going to write that there. Part B, show that 2 to the power of 40 subtract 1 is the product of two consecutive odd numbers. Again, even though it doesn't look like it, this is the difference of two squares, because 2 to the power of 40 is a square number, and 1 is a square number. And by that I mean that 2 to the power of 40 could be written as 2 to the power of 20. Because remember, when we're multiplying and the base numbers are the same, we add the powers. So 20 plus 20 would give us that 40, which is why it's a square. And then we'd have a -1 and a +1. Okay? Now what we can say is 2 to the power of 20 has got to be even, because it's a power of 2, and if we're multiplying by 2, we're going to get an even number. So 2 to the power of 20 subtract 1 must be odd, because the number before that even number would be odd. And then 2 to the power of 20 add 1 is also odd, because the next number on from that even number would be an odd number, because they alternate odd and even. Okay, so 2 to the power of 20 is even. So 2 to the power of 20 subtract 1 is odd, and 2 to the power of 20 add 1 is odd. Therefore, it's the product of 2 consecutive odd numbers, because this is the odd number before 2 to the power of 20, and this is the odd number after 2 to the power of 20. So, but you need to explain that. So I've said that's even, I've said they're odd. So 2 to the power of 40 subtract 1 is the product of this and this, which are consecutive odd numbers. Question 16. On the grid, enlarge triangle T by scale factor -2 with centre of enlargement -2, -2. So this is triangle T. We're enlarging it with a scale factor of -2, and the centre of enlargement is -2, -2. So that centre of enlargement is here. So we're going to plot the journey from this centre of enlargement to each point of this triangle, and then we're going to reverse that journey and multiply it by 2. The negative means we reverse it and do the opposite, and the 2 means we're going to do it twice as far, 2 times as big. So to get from here to the point of the triangle here, we've gone 4 to the left. So negative means instead of going left, we're going to go right. And then the 2 means instead of going 4, we're going to go 8. 2, 4, 6, 8. And there. And then we're going to do the same to this point. So we've gone 3 down, 3 to the left. So instead of going down and to the left, we're going to go up and to the right because of the negative. But we're going to do it 2 times as far. So instead of down 3, left 3, we're going to go up 6, right 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, at this point, you could probably recognise that this point here is going to be 2 times that distance from the one we've just plotted. So it's going to be 4 times that distance, but you've got to make sure you're doing it in the right direction. So from here to here, it's gone to the left. So on this one, it would go to the right. Alternatively, plot that journey again. So we've gone 3 down, 5 left. Do the opposite. So we're going to go up and right, but we're going to go 6 up, 10 right. And then you're going to draw your triangle. So because we had a negative power, we are expecting that it's flipped in some way. And then that power of the 2 in that scale factor, not power, sorry, is what's made it 2 times bigger. Question 17. Here is a distance time graph. So we've got distance and time, and we've got a curve here, and that's important to be aware of. Part A, find an estimate of the gradient of the graph at time 2.5 seconds. You must show how you get your answer. So the fact that it's a curve is important here. When we've got a straight line and we find the gradient, then we do the change in y over the change in x, and that gives us our gradient. We don't have a straight line here, so we need to give ourselves one. So we're going to find time 2.5 here, go up to the curve at that point, and then we're going to draw a tangent to the curve. So what's important here with the tangent, guys, is it touches the curve but doesn't cross it. So we draw a tangent, a straight line at the curve at the point given, and now we're going to work out the gradient of that straight line. Okay, so let's pick 2 points. So that is 3.538, and then if we go with this point here, it's a 1.810. So now we can work out the gradient of this line. We're going to do the change in y divided by the change in x. So the y coordinate is 38 and 10. So we're going to do 38 subtract 10 over 3.5 subtract 1.8. Remember, it's an estimate, so there will be a range of values that you can take from this, okay? So that's 38 subtract 10 over 3.5 subtract 1.8, which is 16.4705. So I'm going to say 16.5 is the gradient. Okay, and I'm going to pop that on my answer line there. What does the gradient of the graph represent? Well, this is a distance time graph. What is the other variable that we use with distance and time? It's speed, isn't it? So this graph, the gradient of this graph is the change in y, the distance, divided by the time. So it must be speed. Question 18. A solid frustum is made by removing a small cone from a large cone as shown in the diagram. So this shape here is a frustum, and what they've done is we started with a large cone, then they've removed the smaller cone from the top to leave this shape here. The slant height of the small cone is 6 centimetres. The slant height of the large cone is 10 centimetres. The radius of the base of the large cone is 3 centimetres. Calculate the total surface area of the frustum. Give your answer correct to 3 significant figures. Now it gives us the formula for the curved surface area of a cone. Okay, so what we're going to do, we're going to find the surface area of this cone, the larger cone, the surface area of the smaller cone, subtract them from each other, and then this will tell us the surface area around the outside of this frustum, and then we need to add these 2 circles. So let's do that first. So the surface area of the large cone, so we need pi times the radius times the length, the slanted height there, okay? So for the large cone, it's going to be pi times 3 times 10, which is 30 pi. I'm going to leave it as 30 pi because it makes my life easier. When I find the surface area of the small cone, I need to know the radius, okay? And it doesn't label that for me, and it's definitely not 3 because the base of the frustum is larger, okay? So what we need to recognise is actually the small cone and the large cone are similar shapes. And because we know the slanted height of each, we can work out a scale factor, and this will be the linear scale factor because we're dealing with height, okay? So 10 divided by 6 gives us a scale factor of, I'm going to leave it as a fraction, 5/3. So the radius of the small cone is 5/3. The radius of the small cone is the radius of the large cone divided by 5/3. So 3 divided by 5/3. 3 divided by the answer. So the radius of the small cone is 1.8. So now we're going to do pi times 1.8 times 6. So 1.8 times 6. So that's 10.8 pi. So if I subtract these 2 now, that's giving me the distance around the curved surface area of the frustum. So 30 pi subtract 10.8 pi. So this is the curved surface area of the frustum. So 30 subtract 10.8 is 19.2 pi. But for the total surface area of the frustum, I need the area of this circle and the area of this circle, then I need to add it to this. So actually the total surface area is 19.2 pi, add 9 pi, because it's pi r squared for the area of this circle. And then this, we said this was 1.8, so 1.8 squared is 3.24 pi. So we've got 3.24 plus 9 plus 19.2. So we have 31.44 pi. We want three significant figures. So let's figure out what 31.44 pi is. So it's 98.771. Three significant figures. 1, 2, 3. That 7 is going to round this 7 up. So it's 98.8. That's the total surface area. Question 19. Sana needs to draw the graph of y equals 3 to the power of x for the range of values from 0 to 4. And she's drawn the graph that's shown on the grid here. So this is Sana's graph. The question asks us to write down one thing Sana has done wrong. So the best way to approach this is to figure out if they've actually plotted the graph correctly to start off with. So if y equals 3 to the power of x, when x is 1, y would be 3 to the power of 1, which is 3. When x is 0, it will be 3 to the power of 0, which is 1. So this graph should go through 1, 3, and it should go through 0, 1. So 1, 3 looks about right, but 0, 1 hasn't gone through 0, 1. It's gone through 0, 0. So that's where I'm going to query this. I'm going to say it should go through 0, 1, and it clearly isn't because it's gone through 0, 0.